Hey, this one will blow your mind. Okay, for this, when you're doing problems like this, where you have to find a higher order derivative, in this case, we're going for the second derivative. Um, you'll proceed as normal, but then when you go and take the second derivative, you're going to be substituting what you found for the first derivative back in. Let me show you what I'm talking about. We need quite a bit of room here. All right, so all right, let's go ahead and get that first derivative. All right, so the first derivative, the derivative of cosine y is going to be negative sine, copy, chain rule. And since that's not x, and we are taking the derivative with respect to x, uh, uh, a dy dx is needed. A dy dx is needed. I don't know what the heck I was writing right there. All right, so, and then the right-hand side is just 1. All right, so that's not so bad. So the right-hand side is 1. So that means that my first derivative, dy dx, is equal to negative 1 over sine x. Negative 1 over sine y. Okay, now, okay, well, that's interesting. Do we want to leave it like that, or I want to write it as cosecant? So I think I do. I want to write it as negative cosecant y. All right, so there we go. So there's our first derivative. All right, and then and so just remember that a little side note here that the derivative with respect to x of cosecant x, okay, is negative cosecant x cotangent x. That's one you got to know. You just got to know it. All right. And so we're going to deal with that in just a second. All right. So then, all right. But here's the thing, and this is going to bring up a really, really interesting point. Since that's not x, that's y. I know we're going to be copying that y twice, but chain rule only happens once because this was one derivative. That's a cosecant y. This is one single derivative we're taking. So one single dy dx is created. Okay. So here we go. Notation. All right. So the derivative, the second one, and here's the notation on that. The second derivative with respect to x. Okay, and that's how you show it. So it's kind of like the y is separated from the thing, and the twos are not exponents. That's just showing that it's the second derivative. All right, will be. All right, this is great. Then it's a negative times a negative. All right, I just want to go ahead and say it's positive. So since that negative is already there, that negative will cancel out, and it will be this. It's going to be cosecant y times cotangent y. Now remember, that was one derivative I just did. So my chain rule is really coming from here. I usually, just for convenience, I'll draw it from the place I came. But since that has been split apart, a lot of people think, oh, well, it's two chain rules. No, it's not, because this is the y that I'm taking the derivative of, and that just happened to be clones. All right, so that's dy dx, and you're like, I did it. Well, not really, because what's this? So I have cosecant y, cotangent y, and we knew what dy dx is because we just found it up here. So that's times negative cosecant y. All right. So I've got negative cosecant y squared cotangent squared. Man, can any of that be cleaned up? I don't think so, because cotangent is, I'm just making a little notation here. Cosecant is 1 over sine, right? And then cotangent is cosine over sine. There's not really anything I can do. So I believe our final answer then is negative cosecant squared of y and times, and I don't think you really need that multiplication, but just kind of do it just because it looks so crazy, cotangent y. And then we are done. Whoop.